Dear students, in this class we are going to discuss chapter number 13, magnetic effect of electric current. We all know what is magnet. An object, it can attract certain objects or it can repel certain objects. Such a type one object that we call magnet. Okay. Normally, we know similar poles, north, similar poles get repel and opposite poles get attracted. South north pole comes closer, it get attracted, and north pole then it get repelled. This is the way the magnetism works out. And here first activity 13.1 is given. Here in the circuit, what are the things arranged? One battery is arranged, and one ammeter, one resistor, and XY part, and one key also. When we switch on this key, current start passing through this conductor. And just you see near the part of XY one compass also they arranged. Okay, what is compass? Compass is a small instrument by which we can understand the direction of the earth, north, south direction we can understand. And inside the compass there is a small suspended magnet is there. Okay, wherever we keep, then the magnet takes the position of north and south direction of the earth. So this is the this type of an instrument we call compass. A very small compass we are placing near the part of XY here. As current passes through the XY part, the compass needle of the compass gets deflected. Okay, that means here the XY part became magnet when current passes through it. That means whenever current passes through a conductor, the conductor itself becomes a magnet. That's why the compass get deflected here. Okay. Once again, I tell you, magnetic effects of electric current means when current passes through a conductor, the conductor itself becomes a magnet or it shows magnetism. To prove that one, here 13.1 activity, it clearly proved. That means XY part when we say allowed to pass the current, then what happened here? The XY part became a magnet, and because of that magnetism, the compass needle of the compass get deflected. Okay, that means in shortly, I tell you, when current passes through a conductor, the conductor becomes a magnet or conductor gets a magnetism. That's why here compass get deflected. Okay, and this concept put forward by Hans Christian Ørsted in 1820, and he gave the name electromagnetism. Okay, 1820 Hans Christian Ørsted, and this name also keep in mind. And come to the next topic, magnetic field and field lines. First, magnetic field. Magnetic field means every magnet having a certain area on which the magnet can influence. That area we call magnetic field. Okay, and beyond the area, if you keep any object, the magnet cannot attract. Okay, cannot influence that object if you keep beyond this area. That means the area on which the magnet can influence, that area we call magnetic field. Then magnetic field lines. We are going to discuss about the magnetic field lines. Before that, here one picture is given 13.2. It is one bar magnet. Okay, bar magnet, and this bar magnet two poles are clearly shown here, that is north pole and south pole. And when we put some iron fillings means small bits of iron material. Okay, iron metal small bits, when we put over this magnet, it will be automatically arranged like this. Okay, more will be concentrated at both the poles and less particles will be concentrated around it, and in this way it will be arranged. And why it will be arranged in such a way, that we are going to study when we learn about the magnetic field lines, we can understand clearly. And 13.3 activity, here 13.3, this figure I am describing now. And here uh, one bar magnet is given here, south pole and north pole, and we are keeping one compass near the south pole. Then what will happen to the needle of the compass? A needle of the compass, the south pole of the needle of the compass shows towards the north pole of the bar magnet. Here clearly given, the compass south pole shows the direction towards the north pole of the compass, because here opposite poles are attracting. That's why south pole of the compass get attracted towards the north pole of the magnet. Okay, and automatically the other end will show the north pole will show the another opposite direction, where we are keeping one point. Okay, mark one point there. Again we are pointing, we are moving this compass towards that point, then it will show another direction. Compass will show another direction. Again you put one mark there. Keep this activity again and again. Okay, do this activity again and again. Then what will happen? You will reach near the south pole of that bar magnet and join this all the points. Then what will get? One line you will get, and this line we call magnetic field lines. Okay, and we can draw so many magnetic field lines around the bar magnet, as they have shown in figure 13.4. Here they have drawn so many magnetic field lines, and these lines, all lines are coming from north pole to south pole. Outside the direction is north pole to south pole, and inside the direction of the magnetic field lines is south pole to north pole. Okay, and related with this magnetic field lines, three properties, three nature we have to understand. First one is, first one I already told, the direction of the magnetic field lines comes from north pole to south pole outside, and inside south pole to north pole. And the second point is, no magnetic field lines intersect each other. Here no lines are intersecting each other. That means because the compass will never show two direction on the same point. That's why the magnetic field lines never intersect each other. That is the second point. And third point is the strength of the magnetism, that is always related to the closeness of the magnetic field lines. Okay, here more and more magnetic field lines you can see at both poles. North pole, more magnetic field lines are closer, and the same way south pole also, more magnetic field lines are closer. Okay, where there is a more magnetic field lines are closer, there more magnetism there will be. Okay, so 3 points I told related to magnetic field lines. One is the direction, that is always from north pole to south pole outside, and inside the south pole to north pole. And second point is no magnetic field lines intersect each other, because the compass never show two direction on the same point. And the third point is the strength of the magnetism is always related to the closeness of magnetic field lines. In this case, the both the poles having more closeness of magnetic field lines. That's why the strength of the magnetism will be more in the at the two poles. Okay, and come to the next topic here. Magnetic field due to current carrying conductor. Magnetic field due to current carrying conductor. We already discussed there will be magnetic field when current passes through a current conductor. Okay, when current passes through a conductor, the conductor itself becomes a magnet, or there will be a magnetic field created. Okay, then this figure you see here, two figure, they have given two figure here, A and B. First we can understand the figure A. And in this figure, uh, one circuit they placed the direction of north and south. The red part, have you seen red part of this circuit in a figure A, red part? And this red part is they already placed in the direction of north and south. Okay, north south direction they already placed that circuit, and over which they placed one compass also. When we switch on the circuit, current start passing through the circuit from north to south, from north to south, because the direction of the current is positive to negative. battery, you just see the battery positive part. Okay, positive to negative, the direction they are already shown by using arrows. Okay, so north to south current passing, and the compass needle get deflected towards the east. Okay, the north to south, when current passes towards the north to south, then the needle of the compass which is placed over this conductor get deflected towards the east. And next figure B, in the figure B, they reversed the point of battery, positive and negative points they are reversed. Then current direction also get reversed. Then in the second figure, current passes from south to north only. Then the needle of the compass get deflected towards the west. Okay, the first figure, position of the battery, you see current passing from north to south. That time the needle of the compass get deflected towards the east, and when current passes from south to north direction, then the needle of the compass get deflected towards the west. Okay, and you can do the same activity. Now we placed the compass over the circuit only, and you can keep the compass under the circuit. Then also the direction of the compass, the needle, that also get changed. And the rest of the portion we will discuss in the next class. Okay.